Okay, chapter 6.2, the system of linear equations in more than two variables. So there are equations. For example, here there are three equations here. And the first equation has three variables, second equation has two variables, and the third equation has only one variable. So actually it doesn't matter. So if there are three variables, then we should have three equations. If there are two variables, then we should have two equations. So the number of equations should be the same as the number of variables. So if we have a system of equations like this, then we call this this system is in triangular form. Triangular form is this. The last equation is for the z variable. So the z value is is given, or the last equation shows the z value. And once you have the z value, then you can find the y value from the second equation, because we already know the z value. Then from the second equation, we got the y value. And from the third equation, we got the z value. Then using these two y and z value, we can find the x values from the first equation. So we call this back substitution. Back substitution. So if we have three equations, then make sure the last equation is the value for z variable. And the second equation, we can find the value of the y variable. So make sure that second and third equation has no x terms, and then the third equation has none of the x terms and the y terms. Okay, then let's find out the solution for this system of equations. Since we know the z value equals 2, so why don't we find the y value from the second equation? So since z is 2, replace z with 2, then plus 2 each side, so y equals 5. So we have the y value. So from the third equation, we know that the z value is 2. Okay, then from the first equation, let's find the x value. So write down the first equation and then replace y and z values. Y is 5. So 2 times 5. Z is 3. Then x plus 10 plus 3 is equal to, z equals 2, right? Z equals 2. Then x plus 12 equals 2. Then minus 12 each side, then negative 10. So the z value is negative 10. So therefore, the solution will be x is negative 10, y is 5, z equals 2. So if we rewrite the equation in this triangular form, then it's easy to find x, y, z values. So let's try example 1 and then rewrite the example 1 in this triangular form. Example 1. Okay, here's a system of equations with system of three equations. So we will rewrite this equation so that will be in triangular form like this. So first of all, let's use the first equation. Okay, first equation is starting with x. So I will use this first equation to eliminate 2x in the second equation and 2x in the third equation. So why don't we multiply the first equation to eliminate x using the first equation and two equations? Multiply the first equation by negative 2. So the coefficient of x will be negative 2. So first we will eliminate 2x from the second equation. Then write the second equation as it is. So multiply the first equation by 2, negative 2, then negative 2x. minus 4y plus 2z is equal to negative 2. The second equation is unchanged. Then by adding these two equations, we can eliminate x. Then this minus negative 5y plus 3z is equal to 4. So we can replace the second equation with this. So look at this. So the first equation is unchanged. The now second equation is replaced by the result that just we got. So the second equation will be now negative 5y plus 3z is equal to 4. Okay, let's do this one. Do the same method. Using the same method, let's eliminate 2x from the third equation. So to eliminate 2x from the third equation, why don't we multiply the first equation? The coefficient of x in the first equation is 1, so let's make it negative 2. So multiply the first equation by negative 2, and then add it to the third equation. So the first equation is multiply the first equation by negative 2, which is same as this result. So negative 2x minus 4y plus 2z is equal to negative 2. And then the third equation is 2x minus y minus z is equal to 0. Add this result. Then we can cancel out x. So negative 5y plus z is equal to negative 2. So the third equation will be replaced by this result. So that is negative 5y plus z is equal to negative 2. All right. So we just replaced the first system of equations into this one. So as you see this, now the second equation and the third equation, let's use a different number. Let's use the fourth equation and the fifth equation. So we have y, two variables y and z. So why don't we, so from this we can solve for z. Let's solve for z, then we can solve for y. It doesn't matter. Actually, it doesn't matter. So let's eliminate z, because eliminating 5 is much easier. But it actually doesn't matter. So if we want to eliminate z, then you can multiply the fifth equation by negative 3. Because this is 3z, this is 1z. So let's make z to be negative 3. So multiply the fourth equation stays the same, and I will multiply the fifth equation by negative 3. Again, fourth equation is negative 5b, negative 5y, plus 3z equals 4. Then multiply the fifth equation by negative 3, so negative 15y minus 3z is equal to positive 6. Then add these two, then this will be negative 20y, cancel out z terms, and then 10. So y will be negative 1/2. There's a mistake. Look at this. Multiply the fifth equation by negative 3. Multiply this by negative 3, there will be positive 15. So this is positive 15. So let's get rid of this. Then add this 2, then there will be 10y is equal to 10. So y equals 1. Y is equal to 1. So we found the y value. So what we found the y value, y equals 1. Then let's find the z value from this. Okay, so from the equation 4, actually it doesn't matter. From the equation 4, negative 5y plus 3z is equal to 4. Then y equals 1. So negative 5 times 1 plus 3 is 4. 3z is 4. Then negative 5 plus 3z equals 4. 3z is plus 5 each side. Then z equals 3. So we found the z value. So let's find the x value. So you can use the first equation to find the x value. Okay, the first equation is x plus 2y minus z equals 1. X plus 2y minus z is equal to 1. So from this, let's plug in the y value and z value. So x plus 2 times 1 minus z is 3. Then x plus 2 minus 3 equals 1. X minus 1 equals 1. So x equals 2. So the solution will be x is 2, y is 1, and z is 3. That's the solution. Well, in this case, look at this. From the equation 4 and 5, we can eliminate 5. Eliminate 5 by making the coefficient of y in the fifth equation to be 5. So if this is 5, then we can eliminate y. Then the third equation can be replaced by z value. So there's another way, another method to eliminate y. So it's important, it's very important. First of all, we have to eliminate one of the three variables, x, y, or z, using one equation. So what I did is, using the first equation, I removed x terms from the second equation and the third equation. Then we have two equations with two variables, y and z. Then using standard method, we can find either y value or z value. Okay. Example 2. Okay, let's solve this system of three equations. Okay, for the equations, the location of the equation, the order of the equation, it doesn't matter. So why don't we switch the first equation, the second equation? So switch these two equations. Then it will be negative x plus 3y minus z is equal to negative 3. Actually, the order of the equation doesn't matter. And then, the reason that I switched interchange the two equations is because if the first equation starts with x, then that is the best. Starts with x is the best. So in this case, why don't we multiply the first equation by negative? Multiply this equation by a negative sign. Then it's much easier. So let's say multiply the first equation by negative. Okay, let me write here. Multiply the first equation by negative 1. Then what we have is x minus 3y plus z is equal to 3. And the second equation is the same. Now what I did is I did minor changes in the system of equations. I just rearranged, and then I made the first equation starting with x, positive x. So let's start from here. So let's say the first equation, this is equation 1, equation 2, equation 3. So using the first equation, let's get rid of x terms from the second equation and the third equation. So what I will do is I will multiply the first equation by negative 2, so that when we add the first two equations, then we can get rid of the x terms. The second equation. So multiply the first equation by negative 2. So negative 2x plus 6y minus 2z is equal to negative 6. And the second equation is unchanged. Then add these two equations. Then we can cancel out the x terms. So 5y minus 3z is equal to negative 7. So we have this equation, and this will be replaced. So the second equation will be replaced by this result. So why don't we write the second equation? Okay, let me write let me write on the right hand side here. So the first equation is this, and the second equation is replaced by 5y minus 3z is equal to negative 7. Okay, let's eliminate now negative 5x from the third equation. So I will multiply the first equation by 5. And then the third equation stays the same. So multiply the first equation by 5, then 5x minus 15y plus 5z is equal to 15. And then the third equation is unchanged. Okay, plus 5y plus z is equal to negative 1. And then add these two, then the result will be substituted for the third equation. Cancel out, so there's negative 10y plus 6z is equals 14. All right, so why don't we replace the third equation by this result? And this result is for the second equation. So there will be minus negative 10y plus 6z is equal to 14. So as you can see this, we eliminate x terms from the second equation, third equation. And this second and the third equation has two variables, y and z. So we can solve for y or solve for z. It doesn't matter. So let's say this is the equation 4. This is the equation 5. All right, so from the last two equations, 4 and 5, let's eliminate y. It doesn't matter, so let's eliminate y. So why don't we multiply the fourth equation? Multiply the first equation by 2. So the coefficient of y will be 10, and then equation 5 is unchanged. Then the fourth equation will be 10y minus 6z is equal to negative 14. And the fifth equation is negative 10y plus 6z is equal to 14. Look at this. When we add these two, what happens? The left side of the equation is all zeros. The right side is also 0. If we have an equation that is true, then what's our conclusion? There are infinitely. This means there are infinitely many solutions. There are infinitely many solutions, right? So you can replace the equation 5 with 0 equals 0. So you can replace this one with what? 0 equals 0. So let me rewrite the equation. System of equations. So all right, so it looks more complicated. So x minus 3y plus z is equal to 3, and the equation 4 is 5y minus 3z is equal to negative 7. And then the third equation is what? The result is 0 equals 0. 0 equals 0. So we have something like this. This is a new equation. So from this new equation, the third equation indicates that what? Z can be any real number. Any real number. So this means 0z is equal to 0. So z can be any real number. This means z is any real number. Any real number. So why don't we set z equals 2? Z equals c. Any real number. So if z value is c, then let's find y. Okay, we know this system of equation has infinitely many solutions. Infinitely many solutions. So why don't we set, okay, let me write down, this is x value, y value, c value. So the type of the solution will be z is a real number c, then let's find y and x. So from the, okay, let's say this is equation 1, this is equation, let's say equation, I used 5, so let's use, this is equation 4, right? 4, same as 4. So from the fourth equation, let's write y in terms of c. So 5y minus 3c is equal to negative 7. Then 5y is equal to 3c minus 7. Then y is equal to, okay, divide by each side by 5. So 3 over 5, c minus 7 over 5. So if z value is c, then the y value will be 3y, 3 over 5c minus 7 over 5. Okay, let's find the type of x value. So we can use the first equation to find x, to write the x in terms of c. So x is, the first equation is x minus 3y. X minus 3y plus z is equal to 3. So let's plug in, lots of work, huh? So let's plug in the y value, the expression for y and z. So x minus 3, y is 3 over 5, c minus 7 over 5, and z is c. So in this case, why don't we multiply? Okay, so this is x minus 9 over 5c plus 21 over 5 plus c is equal to 3. To get rid of 5, why don't we multiply the equation by 5? Can multiply everything by 5. So let me write it here. So multiply everything by 5. Then 5x, you can get rid of the denominator 5. Denominator 5 is equals 15. Then let's solve for x. Okay, combine these two. Then that is minus 4c plus 21 is 15. 5x equals, move 4c, minus 4c to the other side, then 4c. And then minus 21 each side, then minus 21 each side, so minus 6. And then divide each side by 5. Then 4 over 5c minus 6 over 5. So that is the expression for the solution x. So let me rewrite this. So x will be, I have to go all the way up. 4 over 5c minus 6 over 5. So this is 4 over 5c minus 6 over 5. So this is the solution. So we know that there are infinitely many solutions, and the type of the solutions is in this form. And the where c is what? C is any real number. Any real number. So we know that the system of these three equations has infinitely many solutions. So infinitely many solutions is the solution. Then what's the type of the solution? Then the type will be this pair. This, well, what do you call it? Not an order pair, triple pair. So that's the solution type, and the solution is there are infinitely many solutions. Example 3. Okay, solve the system of three linear equations. Okay, the first equation starts with x, so that's good. So we don't have to interchange the equation. So why don't we just get rid of 2x and 3x from equation 2 and 3 using the first equation. So what we can do is multiply the first equation by what? negative 2, and then add it to the second equation. So let's eliminate x. So multiply the first equation by negative 2. So negative 2x minus 4y minus 6z is equal to negative 8. And the second equation is unchanged. Add these two equations. Then cancel out x. So negative 5y is equal to minus 7z is equal to negative 5. So now let's replace the second equation by this result. So what we have is this: x plus 2y plus 3z equals 4. And the second equation will be replaced by our result, which is negative 5y minus 7z is equal to negative 5. And the third equation is 3x plus y plus 2z is equal to 5. Okay, now let's get rid of 3x. So why don't we multiply the first equation by negative 3, and the third equation is unchanged because we want to get rid of this 3. So the first equation should start with negative 3. Then multiply the first equation by negative 3, so negative 3x, negative 6y minus 9z equals negative 12. And third equation is 3x plus y plus 2z is equal to 5. Add. Then we can cancel out x term. The negative 5y minus 7z is equal to negative 7. So now replace the third equation by this result. Okay, so the first equation is unchanged. X plus 2y plus 3z is equal to 4. Negative 5y minus 7z is equal to negative 5. And the third equation will be replaced by our current result. Negative 5 minus 7z is equal to negative 7. So what I did is I replaced the third equation by this, and then from this one, this will be the second equation. So now we have 3 equations. This is equation 1. This is a new equation, so let's use this is 4, and this is 5. So as you can see, this equation 4, okay, using equation 4 and 5, let's get rid of y or z. So let's get rid of y. Let's eliminate this y. So multiply the fourth equation by negative, so it will become, the y coefficient of y will be 5. And then the fifth equation stays the same. So equation 4 times negative 1. So negative multiplied by negative, then becomes positive 5y minus 7z equals positive 5. And the fifth equation is negative 5y minus 7z, negative 7. Okay, so this is, so sorry, this equation is plus. So multiply by negative, so everything will be now positive, 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 yes. And then add these two equations. Then we can cancel out the left hand side is becomes 0. The right hand side is negative 2. All right, so we have a result that is false, and this result will be substitute for the last equation. So the last equation will be replaced by 0 equals negative 2. So if you, okay, let me rewrite this. The first equation is same. The second equation is also same. And the third equation replaced by 0 equals negative 2. Okay, 0 means the left hand side of the equation 0 means 0z, isn't it? 0z. So this means 0z is equal to negative 2. Can you find the z value so that 0 times something is negative 2? This is false, right? False. Okay, this is false, right? False. Even this equation is false. Since this is false, what's the conclusion? There is no solution. There is no solution. Okay. So it's very important. If the last equation is false, then we conclude that there is no solution. Okay, the previous example is what? 0 equals 0, right? 0 equals 0. 0 equals 0 means, okay, the 0 equals 0 is the last equation. Actually, this is the last equation, right? Last equation means 0 times z equals 0. This means z can be any real number because 0 times any real number is 0. So in this case, there are infinitely many solutions because z can be any real number, and then based on the z value, there is an x value and the y value. So the previous example has infinitely many solutions. So whenever the last equation is 0 equals 0, not 1 equals 1, 1 equals 1 is different. 0 equals 0, then 0 equals 0 means there are infinitely many solutions. Then you can find the type of the solution by setting the z value equal to c. But the example 3, the last equation is false. 0 equals negative 2. So 0 equals negative 2 means 0 times z equals negative 2, which means there's no z value. So there is no solution for this system of equations. That's really important. So always check the third equation. If third equation 0 equals 0, then there are infinite many solutions. 0 equals a non-zero value. If the equation is not true, then there is no solution. Okay, example 4 has two equations. There are 3 variables, but there are 2 equations. If there are 3 variables, then we should have 3 equations to find the solution. So since there is one equation is missing, that means the z value can be any real number. The third equation should be, from the third equation, we should get the z value, but there's no third equation, so that means z value is equal to, can be any real number. So anyway, let's get rid of this 2x from the second equation. So we'll multiply the first equation by negative 2, and then add it to the second equation. So okay, let's say this is the first equation and the second equation. Then multiply the first equation by negative 2, so negative 2x. We want to get rid of the x term from the second equation. Then plus 4y minus 4z is equal to negative 6. Second equation is unchanged. Then once we add, let's see what happens. Then we can cancel out 2x, x terms. Then we have 3y minus 6z is equal to 9. And then let's simplify this. Well, okay, let's write the second equation. So solve the second equation for y. All right, then if this equation is divisible by 3, so why don't we divide everything by negative 3? Positive. Divide the equation by 3. Then y minus 2z is equal to 3. So we can replace the second equation with this value. So the first equation is x minus 2y plus 2z is equal to 3. And the second equation will be replaced by this. So this is the second equation. Let's say this is 3. So from the third equation, we can write we can solve for y. Could rewrite the equation. Then there will be 2z plus 3. Then the first equation, if you rewrite the first equation, so that the equation starts with x, Okay, so the first equation is this. And then replace the y value with this expression. Then x minus 2, 2z plus 3, plus 2z is equal to 3. Then x minus 2, 4z minus 6 plus 2z equals 3. So rewrite it. So x, combine this like terms, minus 2z is equal to 3. Then x equals this minus 6. Then move negative 2z to the right, then 2z plus 6 each side, so that is 9. So we can rewrite the x like this and the y like this. So okay, from this one, z can be any real number. Z can be any real number because z is not given. So let's say z is any real number. Let z is any real number, let's say c. Then z is c. So from this one, y is equal to, from the third equation, y is equal to 2z plus 3. So y equals 2c plus 3. And okay, let's say this is the equation 4. Since x equal to z plus 9, x is equal to 2c plus 9. So we know there are infinitely many solutions because z can be any real number. So the solution will be this. The solution is the z value is c, then x will be 2c plus 9, and y is 2c plus 3. So this is the solution. There are infinitely many solutions, and the type of the solution will be in this format, where c is any real number. Okay. So whenever we have an equation, we can assume that in this case, z is any real number. And then rewrite the equation. So it will be x equals something, y equals something, z is any real number c. Then we can find the solutions, the type of solution, which is infinitely many solutions in this format. Okay, example 5. Okay, this system of equations has zeros. The right side of the equation is 0. So the constant part of each equation is 0. Then we call it homogeneous system. And one of the solution is 0, 0, 0 is a solution of this system of equations. And let's check this one. So let's say this is equation 1, equation 2, and equation 3. Alright, since equation 1 starts with x, so why don't we get rid of 2x using the first equation? And also let's get rid of this 3x from using the first equation. So I will multiply the first equation by negative 2 and then add it to the second equation. Also we will do multiply the first equation by okay, we'll do this one later. So multiply the first equation by negative 2. So negative 2x minus 4y plus 6z equals 0. And the second equation is 2x minus y plus z is equal to 0. Add it. Then cancel out x term, minus negative 5y plus 7z is equal to 0. So you can replace the second equation by this result. And then okay, let's get rid of 3x from the third equation. So I will multiply the first equation by negative 3 and then add it to the third equation. So negative 3x minus 6y plus 9z is equal to 0. Third equation is 3x plus y minus 2z is equal to 0. And then add these two results, then we have negative 5y minus 7z is equal to 0. So let's rewrite the equation, the original equation. So the first equation is x plus 2y minus 3z is equal to 0. And then the second equation is replaced by this result. So that is negative 5y plus 7z is equal to 0. Okay, the third equation. Okay, for the third equation, I made a mistake. So 9 minus 7 is positive 7, right? Positive 7. So this plus 7. So why don't we replace the third equation by this result? So that will be negative 5y plus 7z is equal to 0. So the original equation can be, system of equations can be written as this. And as you see this, okay, this is equation 1, this is equation 4, and this is equation 5. So 4 and 5 are same, aren't they? They are same, right? So actually the third equation will be 0 equals 0. You can do this way. Okay, let's try this. So multiply the fourth equation by a negative sign, add it to the fifth equation. Then the result will be replaced by, will be substitute for the last equation. So number 4, equation 4 times negative 1 is 5y minus 7z is equal to 0. The fifth equation is unchanged. Then once you add these two, what happens? 0 equals 0. So 0 equals 0 will be replaced, will be substitute for the last equation. So finally, our equation will be this. X plus 2y minus 3z is equal to 0. Negative 5y plus 7z is equal to 0. And the third equation is what? 0 equals 0. Okay, 0 equals 0 means, okay, 0 equals 0 means what? 0, z is equal to 0. This means z can be any real number, right? Any real number. Any real number C. So there are infinitely many solutions. So for example, so let's find the, rewrite y and x. Rewrite y and x in terms of C. So from the second equation, okay, we know that, okay, from the third equation, actually, from the third equation, z equals c. You know, 0 equals 0 means 0, z equals 0, so z equals c, any real number. And then from the fourth equation, negative 5y plus 7z is equal to 0, so negative 5y plus 7c is equal to 0. Then negative, rewrite the equation in terms of c. Then y is equal to 7 over 5c. Okay, then from the first equation, we don't have enough space, so let's move to the right. The first equation is x plus 2y minus 3z equals 0. So let's replace y and z with, in terms of c. So x plus 2 times y is 7 over 5 c. The minus 3c is equal to 0. So let's multiply 5 each side. Okay, let's finish up this one first. 14 over 5c minus 3c is equal to 0. Then multiply each equation by 5. You know, it's much easier because we don't have to play with the fractions. So we can get rid of 5, the denominator 5 by multiplying the equation by the denominator 5, LCD 5. Then 5x minus c is equal to 0. So 5x equals c. So finally, x is what? 1 over 5c. So we can rewrite the type of each value of x, y, and z in terms of c. So we know that there are infinitely many solutions, right? Infinitely many solutions. And the solution type is x is 1 over 5c, and y is 7 over 5c, and c and z value is c, where c is any real number, So if c equals 0, then c equals 0. So for example, the solution will be c equals 0, then we have 0, 0, 0 is a solution. If c equals 1, then 1 over 5, 7 over 5, 1, and so on. There are infinitely many solutions. So the solution is, there are infinitely many solutions, and the solution type is this, where c is any real number, for example. So actually not this one. So the infinitely many solutions will be this. So the homogeneous system, so 0, 0, 0, if the one side of the equation, the constant is always 0, then for all the equations, then 0, 0, 0 is a solution. The order triple, 0, 0, 0 is a solution, and the solution type, we have to solve it, rewrite x and y in terms of c, then the type of the solution is this. Example 6. Let's find an equation in this form, y equals ax squared plus bx plus c. This is parabola, and the graph contains 3 points. So the graph passes these 3 points. So that means, okay, we will replace x and y. Okay, there are 3 points. 3 points. So why don't we replace x coordinate and y coordinate for the given 3 values, so that we will have 3 equations. Okay, y equal to, for the first point, y value is 4, then x equals 1. So replace x with 1, then 8 times 1 squared plus 5 times 1 plus c. Not 5, that is b, sorry. This is b, right? B. Okay, for the second point, we will have a second equation. Y equals 6 and x is negative 1. So 8 times negative 1 squared plus b times negative 1 plus c. And for the third point, x equals 2, y equals 9. Y equals 9, x equals 2. So 8 times 2 squared plus b times 2 plus c. So let's rewrite this equation. Okay, write ABC first on the left side of the equation. So this will, the first equation will be a plus b plus c is equal to 4. And the second equation is negative 1 squared is 1. So a minus b plus c is equal to 6. And the third equation is 4a. 4a plus 2b plus c is equal to 9. All right, so we have system of 3 equations, and the variables are a, b, c. So let's find out the values of a, b, c. Okay, so this is equation 1, equation 2, and equation 3. So why don't we multiply, okay, get rid of this a from the second equation, and then 4a from the third equation using the first equation. So multiply the first equation by negative and add it to the second equation. Then this will be negative a minus b minus c is equal to negative 4. And the second equation is a minus b plus c is equal to 6. Add it. Let's see what happens. Then cancel out the x term, and negative 2b is equal to cancel out c, 2, so b is equal to 1. We found the b value. So the second equation can be replaced by b equals 1. Okay, and then we will get rid of this 4a using the first equation. So multiply the first equation by negative 4, then add it to the third equation. So multiply the first equation by negative 4, then negative 4a, negative 4b, negative 4c equals negative 16. And the third equation is 4a plus 2b plus c is equal to 9. Add, cancel out a terms, then this is negative 2b, cancel out, negative 2b is equal to negative 7. Something is not to right. Okay, let me double check on this one. All right, when you multiply the first equation by negative 4, and this is negative 4c, not c. So this gotta be negative 4c. All right, so when you add these two equations, then we have negative 2b minus 3c is equal to negative 7. All right, so let's rewrite the equation, system of equations. So the first equation is unchanged. A plus b plus c is equal to 4. And the second equation will be replaced by b equals 1. And the third equation will be replaced by the last one. Negative 2b minus 3c is equal to negative 7. So the second equation is replaced by this result, and the third equation by this equation. So from this, we already found the b value, and then we can find the c value from the third equation. Okay, let's say this is equation 1, equation 4, and this is equation 5. So from the fifth equation, let's find c. Okay, b value is 1, so negative 2 times 1 minus 3c is equal to negative 7. So negative 2 minus 3c is negative 7. Then negative 3c is equal to plus 2 each side. Then c will be, wait a minute, plus 2 each side. One moment. The b value is actually negative 1. Okay, there's a mistake also here. So when you divide this by negative 2, then the b will be negative 1. b is negative 1. So this is equal to negative 1. So from the fifth equation, b is negative 1. So this will be positive 2. Positive 2. So negative 3c is equal to minus 2 each side. Then negative 9. Then c will be 3. So we found the c value, and we know that okay, b value. Okay, from the fourth equation, b is equal to negative 1, right? So we will replace this b in the fifth equation. So we got c value. So let's find the x value. So x value, we can get not x, a value from equation 1. From the equation 1, a plus b plus c equals 4. And then b is negative 1. And c equals 3. So a plus 2 is equal to 4. Then a is 2. So we found the coefficients of the quadratic equation, a, b, c values. So finally, y equals the given value is y equals ax squared plus bx plus c. So let's replace a, b, c with the values that we just found. So a is 2, so 2x squared. B is -1, so negative x. C is 3. So that's the equation of the parabola. So when you solve this one, it's really simple. Replace x values and y values from the 3 given points, so that we have 3 equations with 3 variables a, b, c, and then solve for a, b, c. Okay. Example 7. Okay, this is related to a traffic flow in one direction. So there are 3 junctions A, B, C, 3 intersections A, B, C, and okay, each intersection cars are coming in and cars are going out. So for the intersection A, okay, from this intersection A, 300 and 200 cars are coming into the intersection, and x1 is the number of cars going out to intersection C, and x2 is the number of cars going out to the intersection B. So we can write, okay, for each intersection, let's write an equation. The number of cars in should be equal to the number of cars out. So from the equation, from the junction, intersection A, 200 cars and 300 cars are coming in, and they are going out to intersection C and B. The number of cars are x1 and x2. Okay, from the intersection B, okay, 50 is the number of cars coming in, and x2 is number of cars coming in, and the number of cars going out is, okay, 100 plus x3. Okay, x3 is number of cars going to the intersection C, and 100 cars are going to the northeast side. Okay, from the intersection C, the number of cars coming into the intersection is x1 and x3. The number of cars going out is, there are 2 directions, which is 200 and 250 cars. Okay, so we have just written 3 equations. So let's rewrite the equations and put the xy terms together. So x1 and x2 on the left hand side. Then the right hand side is number of cars, it's numbers, 500. Okay, for the second equation, let's move x3 to the left. So x2 minus x3 is equal to, okay, move 50 from left to the right. Then that is 100. That is 50. So minus 50 each side. Okay, the third equation is x1 plus x3 is equal to 450. So we have 3 equations. 1, 2, 3. So let's find out x1, x2, and x3 from these 3 equations. Okay, here is a condition. x1, the number of cars from intersection A to C is from 100 cars to 200 cars per hour. So the minimum number of cars from A to C is 100, the maximum is 200. That is given. So based on these numbers, we will find the number of cars, the range for the number of cars from A to B and B to C. So x2 and x3. So from this equation, let's use the first equation to get rid of x1 from the third equation. So what we can do is multiply the first equation by negative, multiply the first equation by a -1, and add it to the third equation. So negative x1 minus x2 is equal to negative 500. Negative x1, sorry, positive x1. Third equation is unchanged. plus x3 is equal to 450. Add this result, then this will be negative x2 plus x3 is equal to negative 50. Okay, then why don't we multiply the equation by negative? So we have x2 minus x3 is equal to 50. So let's make a positive number on the right hand side. So the new equation will be x1 plus x2 equals 500. The second equation is unchanged. And the third equation, now replace the third equation with our result. Result is this one. Look at this. The second equation and third equation are the same. See, this equation, this is third equation, right? Okay, this is the equation 3, number 2, and this is equation 4. And these two are actually equal. Actually equal means the third equation is 0. Right, so this means, this implies that, so this means the third equation is what? 0. Means 0 equals 0. So the third equation represents the number of the value of x3. So x3 can be any real number. X3 can be any real number. So in this case, we can solve for, okay, because x values are given. Wait a second. Okay, this indicates that the system is dependent. That means there are many solutions. But in this case, x1 is the number of cars is given, starting from 100 to 200 cars. So if cars are cars from intersection A, so x1, the number of cars from A to C is minimum is 100 and maximum is 200 cars. So let's find, so based on these x values, let's find the values for x2 and x3. So let's plug in. So from this, okay, from this one, the first equation is x1 is equal to 500 minus x2. Then the second equation can be written as x2, well, okay, let me rewrite it, x2. So from the first equation, x2 will be 500 minus x1, because x1 is given starting from 100 to 200. So we want to find x2 from the first equation, and from the second equation, let's find x3. So x3 will be x2 minus 50. Okay, so if x from the first equation, the first equation shows that give us the value of x2. So if x1 is equal to 100, then x2 will be 500 minus 100. So x2 is 400 cars. Okay, from the second equation, from the second equation, we get the number of cars for x3. Then x3 is x2 minus 50. Then x3 is, since x2 is 400, x3 is equal to now 350. So we found the value of x2 and x3 for if x1 is 100, if x equals 200. And then from the first equation, x2 will be 500 minus 200. So x2 is equal to 300 cars. And from the second equation, x2 will be x2 is x3 is x2 minus x3 minus 50, x2 minus 50. So x3 is equal to 300 minus 50, then x3 equals 250. So as you see this, if x1 is 100, then x2 will be between, this is a little bit complicated. So x2 will be 400. And then if x is 200, x1 is 200, x1 is 200, then x2 will be 300. So the range for the x2 will be between 300 to 400. So we can write it as this. Since x is between 100, x1 is 100 to 200, x2 will be between 300 to 400. And for the x3 is the same. For x3 is between 350 to 250. So this will be the solution. So the number of cars from A to the junction intersection A to B is given, which is 100 to 200. Then x2 will be between 300 to 400, and then x3 will be 250 to 350. A little bit complicated, but we can find the solution, find the system of equations using each intersection A, B, C. So there will be 3 equations, and the equation will be the number of input will be equal to the number of outputs. So there are 3 equations, and from these equations, we know that x1 is given. So based on that range for the x1, you can find the range for the x2 and x3. Okay, so x1 is the number of cars from intersection A to C, not A to B, A to C. And x2 is the number of cars from the intersection A to the intersection B, and x3 is the number of cars from the intersection B to C. Okay, so x1 is from A to C, not A to B.